So let me show you how to quickly solve this typical coding interview you might encounter in Google or Facebook or Amazon interview. So normally this is used as a phone screen interview. So let's say it says given two integer arrays a and b and a target value v, determine whether there is a pair of numbers where one number is taken from a and the other taken from one number is taken from a and the other taken from b that can be added together to get the sum of b. Return true if such a pair exists, otherwise return false. So we have the first sample case says a is equal to 1, 2, 3, b is equal to 0, 4, 5, and v is 6. In this case, we can take 2 and 4, and that's going to give us 6. You can also take 1 and 5, and it's going to give us 6. So we cannot take 4 and 5. We can't do 4 and 5. We have to always select from the 2. In this case, we have a is equal to 692, b is equal to 100, minus 1 and 2. We have the v is 7. We can take 6 and 1. 6 and 1, no. 9 and 2, no. So in this case, we return false because we can have 7 taken from the sum of two numbers from each array. For the last one, we have 2, 20, 11, b is equal to 0 to 9, and have v is equal to 20. We can have 20 and 0, and that's going to give us 20. Alright, so the first way we can solve it is using brute force, where we can have a pairwise comparison of all the elements. So we can take 1, compare with 0 to 4, 5, and to take 2, compare with 0, compare to 4, compare to 5, and that's going to give us order of n squared because we are going to have a loop inside a loop. Okay, let's try to solve this problem. So let's use the brute force first, and then we are going to try to improve the algorithm more or less. So let's say for x in a, and say for x for y in b. So I'm going to say if x plus y is equal to v, then I'm going to return true. Otherwise, if it doesn't return true and everything ends, we are going to simply return false. And at this point, if I run it, because this is actually example array given here, 4, 6, 3, 6, 1. Let me see if I can increase the font. Okay, good. Okay, so if I run this now, let's say it returns true. We have 11, so we can take, let's see, 11 can go 9 and 3 or something. 11 maybe 4 and 7, right? So we have 4 and 7. Okay, so let's change this to, let's say, 100, and let's see what returns. So in this case, we have false. All right, so this is a brute force way, and it works perfectly well. Another thing we can do to improve this algorithm, normally we can think of using a hash map. So what it means is, as we iterate through the first array, let me just go back here. As we iterate through the first array, in this case we have 6, we are going to be storing the complement in a hash map. So in this case, the complement of 6, or the complement, the complement for 1 is 5. So we're going to store 5. And okay, so let me just make it look natural. So for 1 we have 5. In this case, for 2, the complement for 6 is 2 minus 6, 6 minus 2. So we have, for 2 we have 4. And for 3 we have what? 3. So we are going to store this complement here. So this x and this is comp. Okay, so we are, in this case, we iterate this list n times, and we are going to iterate the second one. So for 0, we are going to check the 0 exists here. We are going to check if we look at the first item 0, the 0 exists in the list. No, we move to the next one. 4. Does 4 exist? Yes, it exists here, as you can see. So it means that 4 is the complement for 2 to get 6. So in this case, we return true because we have 4 here. Anyway, let's see how it plays out in code using a hash table. In Python, dictionary is hash table or hash map is represented using a dictionary. So I'm going to initialize an empty dictionary called d is equal to an empty dictionary. And so I'm going to start by saying for x in a, I'm going to calculate the complement to be what? To be b minus a, right? to be v minus a. That's the complement, v complement of a, right, of x. So I'm going to store that complement in the hash map as a value for the key of x. So I'm going to say d of x is equal to what? The complement, all right? Okay, so I build up my hash map now. So I've stored the complements in the hash map. So I'm going to go for the second time. I'm going to iterate now through the second array. So I'm going to say for y in b. So I'm going to check if the value, this complement, exists in the hash map or in the dictionary DM. So I'm going to say if y in d dot values, if y in d dot values, okay, give me 1 second. So if y, let's start by saying if y in d dot values, okay, let's just return true. Okay, so if y in d dot value return true, else actually we can just say if y is not if y in d dot values return true. Okay, this is fine. Else, if it's not in d dot values, then and the loop completes, we are going to just return false. Okay, so let's just take a look at this. So if y for y in b, if y exists in the values, we are going to return true. But if it's not and the loop completes, we are going to return false. So let's take a look again at our program. So I'm going to run now, and it says unsupported type for int and lists. So let me give you a second. Okay, so this is v minus x, not v minus a here. So I'm going to run one more time. And here we have false, right? So it works. And let's try to use something else. So in this case, I'm going to use, let me check something that works. So 4 plus 1 is 5, so I'm going to say 5. And I'm going to run it now, and this time it says true. All right, so this is how to solve this problem. So the first one is using brute force, and the second one using a hash map. For the second one, we have 2 iterations n, and we also have a second iteration n. So it's going to be order of n plus n, which is order of 2n, which actually we drop the constant, which is the same as order of n. So it's a great deal of improvement over the brute force method here. So I'm going to be stopping here, and I'd like to thank you for viewing. Please remember to subscribe to my channel if you've not subscribed, and also feel free to leave me a comment, like and share this video if it has been informative for you. I remain kind and the genius, and I'm always there for you.